Climate change, how are we going to feed the world without destroying the planet? How are we going to provide clean water to 1 billion people? How are we going to provide sanitation to 2 billion? How are we going to provide clean energy? And how are we going to take care of the oceans?
For decades, Stanford has had a number of great environmental programs in biology, in the School of Earth Sciences, in civil and environmental engineering. But when you would talk to people outside of the university, they frequently didn't realize what a powerhouse Stanford was in the environmental area.
What's so great at Stanford is that the Woods Institute for the Environment really is an institute of the 7 schools at Stanford. All of us participate, everyone from law and business to medicine and engineering, humanities and sciences, earth sciences, education, we're all in it together. And that's possible because the Institute encourages and facilitates and incentivizes those interactions. I don't think any university can say that. It is one of the things that makes us very special.
We created the Woods Institute for the Environment to do 3 things fundamentally. One is to create an interdisciplinary cauldron of creation where scholars from across the university could come together and address the major environmental challenges of today. 2, we created a forum for collaboration where we could bring decision makers, business leaders, governmental leaders from outside the university to work with us on solving these major environmental challenges. And 3, what the Woods Institute did was incentivize its faculty to work on finding solutions and policy-relevant research.
In Mozambique, for example, we've had a multi-year collaboration with the National Water Regulatory Authority, and we've been working together on research really focused on water supply services for the urban poor. It's been really exciting to see the outputs of that research being taken up immediately into policy decisions. So the kinds of services that are now legal versus illegal, as well as the tariff design, that is the way they structure water service pricing, have really been shaped by our work together with the regulator to be more accessible to the most vulnerable populations.
So there's research that I've been involved in that is really at the global scale, but also research at the very local scale. One of these research areas has to do with the introduction of solar-powered drip irrigation systems in the very poorest areas of West Africa, where these societies and communities have an 8-month dry season where the incidence of very, very severe malnutrition is at its peak. The benefits to these communities have been extremely impressive. You know, a doubling or tripling of women's incomes are involved in the program. Child nutrition has improved across the board, not only in the families who have access to the technology, but also to families who have access to the markets where the fruits and vegetables are sold. So we're really feeling excited that we've got a tool and a product and a process by which to evaluate and see where it works and where it doesn't, and under what circumstance this could be a lifesaver for these communities.
Imagine, for example, in an African savanna, which is some of the research that I've been doing the last few years. If we remove the elephants and the giraffes and the zebras because of poaching, hunting, destruction of the habitat and so on, naturally the vegetation is going to change. More shrubs, more grasses, more hiding places for the little animals. So we discovered that in the absence of the big animals, ecosystems such as the savanna will have an increase in the little animals, rodents, mice, rats, chipmunks, things like that. Essentially, we discovered by doing some experimental manipulations that the abundance of those little animals increased by about 2 times. So my question was, does that have any consequences for humans? And lo and behold, we discovered more rats, more mice, more fleas. More fleas means more risks of disease. Our collaborators are discovering horrible things: Bartonellas, Leptospiras, Leishmanias, Borrelias, even plague, Black Death. We're moving in the direction of informing policymakers, informing medical authorities locally and globally about the significance of deforestation in terms of human disease. We need to be checking for these diseases because maybe they're happening at big rates and we are not even being informed, or people there are not aware of the fact that this is happening.
We know now that about 25 to 30% of our coral reef ecosystems are in grave danger. There are 4 key threats: climate change, over-harvesting or overfishing, habitat destruction, and pollution. And this is really important for humanity because about 500 million people depend in some form or another on coral reef ecosystems, and about 30 million people depend directly on coral reef ecosystems for their livelihoods or for the land that they live on. And there are many things that we can do as communities and as leaders to address these threats and to build the resilience of these systems in the face of these much larger changes that are taking place as a result of climate change. And this work truly has been transformational for many of the Pacific Island leaders. They have concluded that they do need to take action. They've signed resolutions and agreed and committed to take actions within their own countries, and are now asking our community and this broad community of 3,000 plus scientists to help them take the next steps that are necessary to build the resilience for these systems.
We use numerical models that are based on the laws of physics to run the kinds of experiments we would want to run on the real world. And then we compare those climate model experiments with observations of the ocean, observations of the atmosphere, observations of the land surface. One example is the California drought. We're seeing it in natural ecosystems, we're seeing it in wildfires, we're seeing it in the water that's available in snowpack, we're seeing it now in food prices. The atmospheric configuration, this ridiculously resilient ridge, as it's been called, that's causing the California drought is about 3 times as likely now as it was prior to global warming.
So the country that's going furthest in bringing natural capital values into decision making might surprise people. It's China. It's breathtaking to see China sort of waking up to the devastation that has come from pursuing economic development kind of at all costs. And the current government is supporting new policies that have the potential to transform the way China does business, especially with respect to the environment and human well-being. So an example is that they're designating, using our tools, 28% of land area to be secured and protected and restored in order to provide these vital life support benefits to people across the country. The top-level benefits that they're reaching for are flood control, hydropower production efficiency, soil conservation for food security, carbon sequestration in forests for climate stability, and biodiversity for all kinds of purposes and uses.
So we've done a lot of work on groundwater, which is a really critical resource in the West, because groundwater is what helps us get through droughts. When it's not raining, we can take water out of the ground either to drink or to irrigate our crops. So Rosemary Knight and her team in the Earth Sciences School has done really great work on exploring new technologies for remote sensing of groundwater, both in terms of its quality and the level of groundwater, to provide much richer data, much more easily for groundwater managers to make better decisions. So the technology part of it has been a big piece of the work. But we've also had researchers working on groundwater policy. So Rebecca Nelson, who was a researcher in the law school, has done a lot of work on comparative groundwater policy, looking at the policies of different Western states, policies in different countries like Australia, and also looking within California and comparing how different parts of California, different water management districts manage their groundwater, all to find the best tools for sustainable groundwater management policy. And a lot of that work has really fed into stuff that's been happening in California as a result of the drought. So this year California passed for the first time comprehensive statewide sustainable groundwater legislation, and a lot of the work that Rebecca did found its way into that legislation in different ways.
At Stanford, there are literally thousands of students who care a great deal about the environmental and resource challenges facing the planet, and they care, they matter, they are our future.
Now, the Woods Institute is not a degree-granting authority. We do not have our own students per se. So our contribution in terms of students' education will be to provide those interstitial programs that departments and schools ordinarily cannot provide. One such program is called Rising Environmental Leaders, where we take postdocs and PhD students to Washington, D.C. for 1 week where they get exposed to all kinds of people who are making decisions in Washington. They learn about how the decision-making process occurs, and fundamentally they also learn about how important it is to communicate clearly and effectively the importance of their work and what they have to offer in the way of solutions.
One of the great things is that the students leave that week in Washington, D.C. with a much better idea of how they can use their careers to advance environmental decision-making in the United States and the world as a whole. And I've had numerous students come up to me and tell me that of all of their experiences throughout their education, nothing has meant more to them than realm.
Students have always been at the core of what the Woods Institute is about. Students are the ones that have gone and organized faculty into collaborative and interdisciplinary teams.
What's great about this is it gives students the opportunity to be involved in every stage of research, from the conception, right, thinking about what's important, what's an important problem, and then designing research that's really targeted to get the answers that we need, being involved directly in the data collection and engaging with those partners in the field.
They're my ears and eyes on the ground. They're the ones that are doing field work in different countries, Chile, Kenya, China, Brazil, and they're the ones that are not only spending time to get to really understand what the issues are on the ground, but finding the solutions.
So the students are really an essential component of the life of a scientist. They only need sometimes it's an exciting idea, an exciting project, and then they will essentially take over.
So our students are taking the knowledge and skills that they've acquired and developed while here at Stanford and moving out into the world. I mean, they are the agents of change for that innovative yet socially and environmentally responsible sort of change that we're all hoping to see more of.